Good afternoon, everyone. Welcome to session 22, the 22nd session of this program. It's nice to have everyone here once again. So today we're going to pick up from where we stopped in the last class. So the title of this session has been changed actually. We're going to continue with data preprocessing and just like solidify what we explained in yesterday's class, right? With examples and all of that. So we're going to do that in today's class and fix a class within the week. Hopefully, I'm not certain about that yet, but I'm looking at it so we can cover up some other things we need to cover up. So today we're supposed to actually look at other ML algorithms, but I don't know if time is going to enable us to do that. So we will just finish up with data preprocessing and kind of fix up a class within the week to wrap up with the other topic. All right. So I'm also going to go through the project guidelines and all of that in today's class, because the project immediately after this class, so either this night or tomorrow, you're going to be getting your project. So your project is kicking off immediately, right? So after this class, your project is kicking off and it's going to last 2 weeks. I'm still looking at the possibility of extending it a little bit, but just have it at the back of your mind for now that it's going to be lasting for 2 weeks. Okay, so it's a good thing that we are all here, right? We are wrapping up with the program. It's been a good journey. It's been a ride so far. And I'm still encouraging you to stick because we are not done yet. We are actually not done. Even though we are at the finish line, we are actually not done. We still have some things to cover as regarding ML. So I will try my best to cover all of that and make sure that we are up to speed. Okay, so Let's see. I'm going to be sharing my screen because I want to take us through the project that I'm going to be releasing after this class. Okay. So just give me a second there. And sorry I didn't start with that. Happy New Month, everyone. So today is actually the 1st of June. Happy New Month, everyone. I wish you all a very splendid and productive month. So we're going to wrap up this program this month and then call it a day. So let me share my screen. I'll just quickly go through that. All right. Okay, so please let me know if you all can see my screen. Let me know if anyone can see my screen. All right, great. So on the screen, you're going to see project document, which I'll be sending after the class, right? So this is the Youth Drive Data Science Capstone project. And the project is going to be on income level prediction. So basically what you're doing in a general sense is that you're going to be building a model that will be used to predict income levels, right? So the data set is going to be provided and every other thing that you need. So the project timeline, as you can see here, is going to be lasting for 2 weeks, from 1st of June to 14th of June, right? So today is 1st. So officially the project is starting today. I'm going to put it up on the platform. So yeah, I'm going to come to that. I'm going to come to how you submit and access the project. So the project deliverable, what you're expected to submit is a Jupyter notebook, right? So just a Jupyter notebook containing all your code and non-code tasks. So I'm expecting you to submit a Jupyter notebook, and you know the format in which a Jupyter notebook is. That is an IPYNB file. So if you submit any other thing, just know that you've messed up your project. So the overview, your project basically is going to be centered on developing a machine learning model to predict whether a person's income exceeds $50K per year based on census data. So you're going to be given a data set, and that data set will be used to build a model that can predict someone's income. Okay, so it's a binary task, a binary classification task. So I believe that should be like something you're already familiar with. So that's the aim of the project, to predict. So you'll be building a model that will be doing this basically, right? And you'll be leveraging various census data. So as I said, the data set will be provided. So you would also have to explore the data, engineer relevant features, build and evaluate your predictive model, and provide insights from your data. Okay, so this is just it's not a complete end-to-end because you are not deploying this project, right? But I think this is a very good summary of everything that we've done so far. All right, so as you can see here, I said feel free to be creative about the different ways you can make your model better. So one thing that you're going to be doing in this project is trying to improve the performance of your model, trying to make your model perform very well, right? So you are aiming at a very good metric, right? If it's accuracy, you're using precision recall, RSA, UC score, whatever it is, you're using to gauge your model. You're trying to push it to have a better value, all right? So these are the different steps, the guidelines to follow. So you'll be collecting and preparing your data. All right, so since the data is in a file, you'll be loading it and importing it from wherever it is you store it. And then you do the initial data inspection, right? So you can see all the things that, this is just like a guideline basically to help you know what to do, right? So you're also going to be performing EDA. Can everyone see my screen? Please let me know. Everyone can still see my screen. Because I think something just, all right, perfect. So you're going to be also performing EDA, exploratory data analysis, all right? So, and in the EDA, you're expected to generate at least 5 meaningful insights from the data with appropriate visualizations. Okay, so this is the EDA part. You are meant to explore your data, and at the end of your exploration, you generate at least 5 meaningful insights from the data. So this is the analysis aspect of it, all right? So I'll require to see charts and all of those things that we've looked at already. So the next step is to process and engineer features, right? Feature engineering. So these are the different things you'll be doing: handling missing value, encoding categorical variables, feature scaling. All right, so these are just examples. You can also try out different feature engineering and preprocessing techniques like PCA, feature selection, etc. All right. So, but this is also a guideline, a baseline for you to start your work. After then, you can now move on to your model development, right? So you know the route we've taken so far. You split your data after you've preprocessed, then you select your model and then go ahead to train it. So you can choose whatever machine learning algorithm you want to use. So you can look at the different classification algorithms that we're going to look at. So we've looked at just logistic regression so far. And today we're supposed to look at other algorithms, but we're going to fix a class for that, right? So we're going to use that class to exhaust all the other algorithms we have, from KNN to SVM to ensemble algorithms like random forest and the likes, right? SGBoost and other boost and all of that. So we're going to also introduce you to other algorithms, right? So that class is basically a knowledge class. So you understand how these algorithms work and their peculiarities. But the implementation is the same thing that we've been doing so far. So the only thing that changes is the the particular model class you're importing. You'll be importing, let's say you want to use decision tree, you have to import decision tree, and then the other difference is the parameters basically, right? So we're also going to look at hyperparameter tuning as well. I believe that should be next week. So we should look at hyperparameter tuning and some other things like regularization to prevent overfitting. So we are actually not done with class yet, but this project is going to proceed along with the class. So as you're doing your project, we are like basically still looking at some other things. So, and as I said, normally we are supposed to have almost concluded with the class. We're a little bit behind because for some reasons, we are behind schedule. So by now we should be concluding, right? So the project should come at that point. But yeah, I think it's still fair enough. So you kind of just walk along and just run along with the project as we have in our remaining classes. So then these are the remaining things. Model evaluation, right? So since this is a classification model, you're going to be using your classification metrics to evaluate your model. So it's essential that you get that, all right? Then you have your summary and recommendation. So when you finish a project, obviously you should not just leave it like that. You should give a summary and recommendation. So you summarize key insights from your EDA, highlighting any patterns or trends observed in the data. So you also discuss the performance of your machine learning model, its effectiveness in predicting income level and how it can be improved. And all of. So these are the two major things that I expect. So this is the data analysis part, where your EDA part, basically, I just need you to summarize the EDA, point out the difference. So this particular part where I said you generate at least 5 meaningful insights, I am expecting it to be in this place here, this summary, right? So this summary should be where you have your key insights. So you kind of just pull them all down, and then we have that for that. So then you move on to discuss the performance of your machine learning model. So I need you to actually look at what you've done, discuss it. So you talk about the metrics you used, why you choose that metric, and if the performance is actually good enough, and if there are some techniques that you could have used or applied that will make your model better. So I want to put you into your mind into action. So you think about what you are doing. So you don't just do, but you actually think through what you are doing, all right? So every single thing here carries marks. So this is how the grading will be. I like to be very transparent. So this is how the grading will be. So we have 12 sections generally. So the project introduction is going to have 5 marks. So you are doing a project, so you should actually have a project introduction, just summarizing what the project is all about, and just not something lengthy, but a very brief introduction. And you're going to have the library's import structure. So the way you import your library will also be looked at, right? So it has a mark too. We're also going to look at data exploration and cleaning. So the preliminary stage is where you clean your data is going to carry 10 marks. Your EDA aspects, exploratory data analysis would carry 15. I think this is the highest, right? So because you're expected to actually do quite a lot there. So this will be having 15 marks. Data processing and feature engineering will have 10 marks. Hyperparameter tuning, 10 marks. Model evaluation, 10 marks. Model performance, 10 marks. So model evaluation is different from model performance. So model performance basically is the performance of your model after all you've done. So if you are having an accuracy, let's assume you're having accuracy, and you are having an accuracy of 80%, right? That 80% is your model performance. So based on that, you're going to have a particular mark. If you have 90%, you're going to have a particular mark. So your model performance also is going to be considered. The insights from your EDA basically would also be considered. So this EDA here is different. This EDA that is actually the process of you performing the EDA, the techniques that you used, the method and all of that, the chart, the way you structured your chart, the aesthetics of your chart, and the statistical methods and all of that, whether you use group by or whatever it is, right? So I'm going to look at all of those things and then give you your mark for this EDA. But this insight it has to do with the insight that you got, right? That you are going to be writing out from your EDA that you've done. So we also have recommendation here. So recommendation basically is what I explained here, right? And then we also have some marks for code clarity and comments. So if you have a project that is kind of messy and I can't figure out what you are doing, but you actually did something, you probably miss some marks. So I need you to have a very good structure. Remember, we also have the overall project structure and organization. It has 5 marks. Why code clarity as well? So these two would be considered. So I expect you, as well as you're doing what you're supposed to be doing, you should have a very clear, understandable, well-structured project. So all this should be in your Jupyter notebook, and I'm expecting you to use your Markdown very well, right? You should use Markdown very well to organize your stuff. Use your code cell, your Markdown cell. Use the different Markdown text formatting features that you've seen so far. So this is just it, right? So this is the project generally, and I'm going to just like give a few minutes for questions. So if you have any questions, just drop it in the chat. I'll be going through that. So I'm just going to give 1 or 2 minutes for questions. So we kick off or we go straight to what we have for today. If there's any question regarding the project, please drop it on the chat, on the live class chat right now, so I go through it and answer it. If there is none, then we move on to what we have for today. So I'm just going to give some few seconds. If I don't see anything, then we'll move. I assume we are all clear and we understand exactly what I've explained so far. Okay, let's remember that actually the format or the way we'll submit the project. Yeah, I'm going to talk about that. But let me see if there's any question. But while the questions are coming up, let me quickly show you let me share my screen again. All right. Okay. So as you can see on my screen, you have a particular Google form. So this is where you'll be submitting your project, right? So each person, this link would be uploaded on the platform. So the same way you get access to your assignment links, the same way you get access to this Google form link. So I'll post it on the platform and title it project, all right, capstone project or whatever. But you will see it there. And then once you click on the link, it will take you to this particular form, and then you fill the necessary information. So you put your name, student ID, your email address, and then your project link. So this project link is the same link that you will always be submitting for your assignment. So you just get that link and submit it here. So you paste it here and then you click submit. So once you do that, you've submitted your project. You don't need to do anything on the platform, right? You don't need to submit your project on the platform. All you just need to do is to click the link on the platform to take you here, and then you fill up this information, and then you are done. All right, so I think that's just it for submission. All right, so yeah, I'm going to drop the guideline once we are done with this class. I'm going to drop it in the material and resources group. I'm going to drop that once I'm done. Everything will be made available, both the data set that will be used, everything will be made available. Right? Actually, I'm going to drop I'm going to drop them here. Yeah, it will be made available. What do you say about exploratory data analysis and EDA? I mean, the difference in the project. They are the same thing, actually. Like, what I was differentiating was these two parts. Let me come back to it. So. Okay, this is from Kechika. So you asked this question. So what I was saying about the EDA is this particular grading structure, I say you have marks for your EDA itself, and then you have marks for your insight. So if you perform your EDA, you get this mark, but if you don't give your insights that you get from your EDA, you lose this mark, right? But if you perform your EDA and you perform and you give your insight, you get your full marks, right? So that is basically what I was talking about. So I think that should be clear, right? So yeah, don't want to waste much time on this. Let me see if there's another question. Please, Joseph Chimezie, can you throw more light on how someone can read and understand documentation in Python? The thing is just the more you get, there's really no structure to reading documentation. You basically just start from the point that you don't understand. You don't go to advanced documentations and say you want to start reading it. You start from small. You read the ones that are easier to read. From there, you can just build up. I believe the documentations are structured in a way that you can understand. All right. So there is really nothing else I can tell you about how to read and understand documentation other than just reading it and understanding it. Yeah, Chinyere, this project detail will be it will be yeah, the details are going to be made available. Don't worry, after this class you're going to see it. I did young Moses. Can we write insight after the EDA? Yeah, sure. As long as the insights are there, I don't mind, right? But just make sure that you have those insights, basically. So you can write it like, let's say, immediately after each EDA you've done or you do, or you can write it after the end of everything, like just summary at the bottom, at the end of the notebook. So I won't really say much again. Just like figure out how you structure your project, basically. So that's it for your project. So I'm going to be sending out the details after this class, and I wish you Godspeed. So it's really nothing much. It's actually just what we've been doing so far. It just requires you to think through everything step by step, right? And follow it through from where we started to where we are currently. Okay, so let's go straight to what we have for today. So okay, all right, so we have this. All right. So yesterday we started with data preprocessing. We looked at what data preprocessing is basically and how we can perform some preprocessing using some techniques that we looked at. All right. So there are some things I want to talk about today. So there was a correction I posted on the group yesterday after yesterday's class, right? So there was a mistake that we did, or that I did when performing OneHotEncoding. Okay, so I'm going to show us that now. Let's see. Right. Okay, so let me just zoom in. We have started class already. So just pay attention. I'm going to just use this class to wrap up with data preprocessing. All right, so in yesterday's class, we did something that wasn't correct. I actually saw that there was a problem, but I really didn't look at it to debug it, right? So, but yesterday I did something like this. After we imported our data type, we had trip type, which is trip type is one of the variables in our customer bookings data set. So it's a categorical variable, and we needed to convert that into numerical values, all right, via OneHotEncoding. So I did this, and then I went ahead to put the bracket on this. So like what I was doing here wasn't the correct way to do that. So what I should have done was to, let me just bring this, was to actually put the brackets here around this particular column. So while we are calling df that column, we're supposed to just wrap two brackets around it, all right? Not just one. So this is just to ensure that it is two-dimensional, right? So this is where we are supposed to enforce the two-dimension and convert our feature or our variable to two-dimension, not in this particular format. So what we are doing here is something like this. We're doing something like this. So this really doesn't make any sense. Like if I come here and it won't really make any sense. They're just wrapping the entire thing in a bracket. You can see the bracket here. You're wrapping everything in a bracket. So we're supposed to just bring this bracket and put here. So it should have been something like this, not the other way around. All right, so you can see it here. It should have been something like this. All right, so it's now going to be 50,000 rows and one column. So I hope you're taking notes. So come here, just put this here. So once we do the convert to two-dimension here, we don't need to do that again in this particular fitting method. So we can just remove this. All right, we can remove this. I remember our sparse output parameter. By default, it is what? Is it true or false by default based on what we... Oh, you can see my screen. I'm sorry about that. Can anyone see my screen? Did my screen go off at any point, or like it didn't actually had any issue? Or there wasn't any issue? But I think about 3 persons just complained that my screen is blurry, can't see your screen, cannot see your screen, no screen size. So I just want to confirm. Okay, so those that had those issues, please just check out your end if your network is stable or probably there's an issue from your side. Okay, so let's continue with what we were discussing. So now I asked the question: is the value for sparse, the default value for sparse output, is it true or false? So quickly, we mentioned that in yesterday's class. Is it true or false? Okay, so persons are saying true, some are saying false. So who is correct and who is not correct? I need more responses. I actually need as many as possible to interact in this class. I need a lot of interactions in this class because I think that is going to kind of help you to understand better what we are doing. It helps you engage the class, right? Once you're like responding, it helps you engage in the class. So kind of sometimes your mind might be kind of wandering and then you just lose track. But once you are kind of responding to questions and all of that, you are constantly being engaged. So it helps you as well. Okay, so the default value for sparse output is actually true. All right. So Hioma, I never watched yesterday's class, but make I follow people talk true. All right. So yeah, you are correct. This time, following the crowd has helped you. So the correct output is true. Right? If you just come here and do our shift and tab, you're going to see that sparse output default value here is what? True. I remember what I said about sparse output. Sparse output is a way in which Python stores the one-hot encoded feature and values, right? Because when you do one-hot encoding, you're actually converting your features to ones and zeros, and it can come to a point where you do a lot of conversions and then you have a lot of ones and zeros, which can take up memory and make things inefficient. So sparse output by default is true. Storing it in a kind of more efficient way. So that's not the point of this class. We're not trying to go into memory storage or how to how these things are being done, but I just need to understand what sparse output mean. So if we come here and just change this to true, and then we fit our stuff with this data and then run it, and we come here and use the transform method on the same data. So we're going to so I don't think we've run this stuff here, so I'm going to rerun it here. All right, I'm going to come here and rerun our listing so we don't get any error. So I come here and transform. Remember, fit just kind of stores it. So I'm just going to recap on what fit does exactly. Remember in yesterday's class, I said that we have two methods basically that are used in preprocessing, which are what? .fit and .transform. So .fit is like planning to do something but not doing that thing. That's what fit does. For instance, let's just say you want to cook, you want to make a particular dish. Let's say you want to make spaghetti. So the first thing you do is just to kind of plan in your head, like, okay, I'll need to get I need to get spaghetti. I need to get sachet tomato. I need to get onions. I need to get granola oil, this and that, right? So you are trying to plan or map out how to make that particular spaghetti, right? Planning everything and kind of doing it in your head, basically, right? But it doesn't translate to anything. You are not doing anything. You are just planning in your head. So that is what .fit does. It kind of plans, kind of learns from the data itself, right? Just look at the data and understand how to transform that data, basically. So it stores it in its memory, right? So when you now move on to transform, so transform is going to be like moving to the kitchen and using all those plans you have in your head to make that spaghetti. So that's what transform. Transform is like performing the action. All right. So this is just to help you understand more what this two method does. So in this case, we've already fitted our data transformer object, which is this OneHotEncoder object, to our data here, right? And then we come here and then apply the transformation on it. So you're going to see that we get this output, right? We get 50017 times 4 sparse matrix, right? With 5001 stored element in compressed sparse format. So what this is telling you is that the output of this our transformation, of this one hot transformation, is being stored in a sparse format, in a compressed sparse format. So it's basically like an efficient way to store those kind of matrix, right? 0 and 1, 0 and 1, 0 and 1, 0 and 1. So that's because we enabled true here, right? We said we set our sparse output value to be true, which is actually default. But if we come and change it to false, you are telling Python that, okay, I don't want you to store this in an efficient way. Just give me the value, store it the same way, store it exactly as it is, right? That is what the sparse output equal false mean. So we fit it again, right? And then you can see here sparse output equal false. And then we come to transform and apply the transformation. So you're going to see that there's a difference here, right? We are having an actual output, unlike the other one where we sparse output was true. You can see here we have what? We now have four rows, sorry, 4 columns and 50,000 rows. So each of these column here corresponds to what each of these particular category. Remember that this is a feature, this is a particular variable. So this particular variable has 4 categories. So in this case, we've not dealt with our missing value. So it's considered a category. Let's just work with that. So that is why we have this here. If we have more, we're going to have like more columns here and rows. So this is how the one-hot encoding is being represented. Remember when I explained it here, you can see that we have our feature here, feature 1, which have 3 categories. And then after applying one-hot, it will now convert each of the category to a feature. We're going to have each of them here, and then going to be one-hot encoded. So for every row, right? Sorry, for every row for that particular feature, you can have only one, or you would have only one column that has the value of 1, right? So in this case, this category 1 has 1, and then the remaining categories, right? The remaining columns are 0. So once this one is 1, the rest will be 0. Once this one is 1, the rest will be 0. This one is 0, 0, then the last one will be 1. So that's why we call it one-hot encoding. One-hot encoding. So you would have just one particular column that has the value of 1, right? And the rest will be 0. So if, let's say, you have another feature that is a categorical variable that has like 5 categories, that would now come here and be represented as features or as new columns, and then they are going to be one-hot encoded the same way we have this here. All right, I believe this should be clear by now. So that's for one-hot encoding. And remember, I said something yesterday that we can actually convert this to a data frame if you want to like appreciate it, right? So there is a particular feature, a particular method you can use to get the feature names for this output. So you can see here that we used one-hot. So this is our transformer object. So internally, it has some attributes, right? Or some functions that will give you some value. So it has one, which is get features name out. So this is what we're going to have here: trip type, cycle trip type, one way, trip type. So it has 4 of them here. So you can easily just come here and say, okay, let's create a Pandas data frame from it. You can say Pandas data frame, and then we're going to call on this. So what we will do is just assign this to a variable here, and then you can say output, and then we can actually set our columns to be this. You can just say columns. So I hope this column name is correct. Column, right, great. So if you run that, you're going to get this. You're going to get the one-hot encoded values, right? So you can see now that we have 4 new columns. These 4 new columns correspond to, let me call this one out. These 4 new columns correspond to let me make this. Let me just make it head. So these 4 columns correspond to this particular 1 column here, right? So we one-hot encoded this column and we got this. All right. So you can see how it has expanded this stuff here to 4 columns. So if you do the same thing for sales channel, let's do the same thing for sales channel, right? So, and there's something that I actually want to point out. You can actually perform this transformation on multiple columns at the same time, all right? So you don't need to do them 1 column at a time. You can perform it on multiple columns at the same time. All right. So let's demonstrate that. So where is that big boy? Okay, so we have trip type here. And we have, let's look for another column that is a categorical variable. So let's use sales channel. All right, so we have sales channel. So I'm going to come here and just add sales channel to this column here, and I'm going to say columns. I'm going to run that. I don't think I need this anymore, so I'm going to remove it. I'll come here and just say columns and then run this. So it is going to do exactly what we have asked it to do. So come here and say columns, transform. All right, we did that. And then we're going to say column get feature. So if I check the output, let me just check the outputs, right? So you can now see that we have more columns here. If I say output.shape, I have 7 columns because I added another column to categorical column. So you can actually just add all your categorical variables and do one hot encoding at once instead of doing it singly, one after the other. So we do this. So get feature name. If I do that, I'm going to get this. So you can see that I have what? Trip type, cycle trip type one way, trip type round trip type NAN because we've not removed NAN yet. Now we now have sales channel. You see now that this is now the next feature, sales channel, internet sales. So that's basically how we're going to have our one hot encoded feature. So that is basically what we do. And then we can just come here and say df output and column. So if I do this, I'm going to get all of them in one big data frame. So you can see how these are just 2 cool features from our original data set, and now we have them to be 7. So you can see how these ones and zeros can be very, can just blow up. Like depending on the number of categories you have, you can actually blow up. So let's say you have 10 categories in script type and you have 15 categories in sales channel. If you do perform one hot encoding on them, you're going to have 25 new features or 25 new columns, basically. All right. So that is why, by default, OneHotEncoder stores the output as a sparse output, making it efficient. So this is just for you to understand. It's a visualization for you to see exactly what's happening, but in memory, it works differently. That's if you set the sparse output to be true. Okay, so let's move on. I'm just trying to go back to what we did yesterday. So I think we also did the same thing for what is called a SimpleImputer. All right, so for SimpleImputer, we're supposed to, this is not what we're supposed to do here. All right, so it's supposed to be something like this, and then you just put it there. All right, and then you run that. So you take note of this. All right, please take note of it. Take note of it. So the only for encoding categorical variables, the only transformer object that we don't have to convert to 2-dimension is what? This is a question. I'm expecting responses. I mentioned that there's a particular transformer object that we don't need to while fitting it, we don't need to convert it to 2-dimension. There's one of those transformer objects that we mentioned yesterday. So which of them is that? As I said, I need as many responses as possible. All right. So at this point, you are the one holding me here. So I need as many persons as possible to respond. I know whether you are copying what the other person has said and pasting it, that's fine. I don't really care. I just need responses. I need you to be involved. All right. So you are laughing, Mioma. Okay. So yeah, that's it. You're all correct actually. It's label encoder. And can someone just give me the reason quickly? Why is it so? Why is it so? Why is it so? Quickly. Let's see. Why is it so? Why is the label encoder not following, or why does it not follow the same pattern as we have for other encoders? So there's one, it's one thing to know an answer to something, and it's another thing to know why that answer is the answer, or why it is so, basically. Okay, you're saying it's already in one dimension. Yeah, yeah, basically the answer is because it's the output variable, the label, it's the target, right? And the target is expected to be just one value or one dimension. So it is that expectation that that the expectation of it being just one value is what label encoder works with, right? So for other encoders that involve the features, it actually expects more than one feature, meaning that it expects more than one dimension. It expects a two-dimensional object, right? So that is why we have to do that for that. So as I said, label encoder is used to encode your labels, right? It's used to encode your labels. Okay. So that is it for that. That's it for that. So let's move on. Let's move on. So we also did which one again did we even do? So we did normalization, right? So let me see this. Okay. So we did feature scaling. This feature scaling basically. So we have two of those, right? So can someone just remind us of the two techniques we use to scaling our features? So this is just like a mini revision. Can someone just tell us the two techniques we use in scaling our features? Okay. All right. All right. So we have normalization and standardization. Okay, these are the major two or two basic feature scaling techniques we have. All right. So we looked at it yesterday and we looked at how we can actually implement it. So we have what we call normalization, which uses min max scalar. And we also have standardization, which uses standard scalar. So I feel that that is clear. So if you need to scale your features, you can use either of them. And I told you when to use either of them, right? So when your data is normally distributed, which one do you use? Okay, let me just try this thing here. All right, all right, that's correct. So standard scalar is basically the scalar that we use when mostly correctly put, it is used when the algorithm we are using assumes a normal distribution, assumes that our data are normally distributed. All right, so it just has to do with normal distribution. But if the algorithm you're using doesn't really assume normal distribution, you can just use your mean max scalar. Okay, but the thing is that there are a lot of assumptions to check before doing ML. So most people just go straight to building our models, and once our models start misbehaving or it's not giving them, then that's when you now start checking all these assumptions to be sure that you are not missing any one of them. So if you miss any one of them, you can easily just like trace your way back and do that. So for your standard scalar and mean max scalar, you can easily just import it, either of them. So you can import mean max scalar here. And let's import standard scale. Okay. And just say M scale. Okay, so come and see standard scalar. I'm gonna also do this. Scaled 1 without scaled 2. We have M scaled here. We need to have standard scale here. We want to print both of them out. So print scale 1 and print scale 2. So standard scalar is not defined. So see if we can import it. And then okay, should be okay, E, not A. So if you get your spelling correct, it should run perfectly. I'm going to put E here, I'm going to run it. So purchase list is not defined. So let's put this in a string. Come here and do this, and then do this as well. Then do this again. If I run that, if it gives me an error, I'm just going to throw the system away. So this is basically what we're going to expect, right? So you see that that's scaled our data here. Let me print this. Let me make this. This is mean mass scalar. All right. Okay, so you can see now this is our standard scalar. This is our mean mass scalar. These are now. So these are the same, exactly the same values. All right. So mean mass scalar limit your the scale between 0 and 1. So if you check through all the scaled value here, you will never see any value that is greater than 1 or less than 0. Right? But standard scalar does a different thing. It uses your mean and some other values to calculate the new value for each data point. All right, so you can have values that are on the negative side, values that are on the positive side as well. So it differs based on the distribution of that particular data, but it still puts it with being a particular range. So I think you really put it between a particular standard deviation. Let's say my standard deviation times 2 or standard deviation times 3. If you are familiar with statistics, you understand what I'm saying. So it can be between -1 + 1, -2 + 2, or whatever it is that, depending on your data, basically. So that is just the standard scalar and the min max scalar. So this is the data you would use, and this data you use in your training, not the original data. So these are just the things that I needed to bring back, so you get to understand better. So now let's see a kind of end-to-end process of how we can just use the data sets and build a model. So this data set we have here is not an ID data set for building model, because most of the features here, they don't really make sense. And but let's just go on. They don't make sense for predictions, basically. So let's just use this to illustrate. So I said we're going to actually do this into this class. So let's get ahead with it. I'm going to have a markdown here. This is going to be building a logistic regression model with data sets. Okay, so this first step here is what? Import your data, right? No, the first step here actually is to import your libraries, right? So you come here, import libraries. Those libraries you know you might need. So just most times what you do, import Pandas and Speedy, import NumPy as NP. You can say from matplotlib, import pyplot as plots. You can also actually import Seaborn as well, right? So import Seaborn as SNS. Now you can now move on. So since you know you are building a logistic regression model, you can start importing scikit-learn functions and classes. So import from scikit-learn dot. Let me just ask this as a question. Where do I import? Which module do I import logistic regression from in scikit-learn? So let me not just go solo. I need you people to take me through. So which module do I import scikit-learn from? Sorry, logistic regression. I said scikit-learn. Don't mind me. Which module do I import logistic regression from? Okay, the attendance is not open. Yeah, it's going to be open now. I'm going to open it now. Just give me some second. It's kind of delaying a little bit. All right, the attendance is open. You can all start your attendance. All right, great. So yeah, you import it from linear model module. Okay. So you import it from the linear model module. All right, so come and say linear model, import logistic regression. So obviously I'm doing a classification. I'll need metrics like accuracy and stuff. So I'll just say from scikit-learn, what module do I import my metrics from? What module will I import my metrics from? All right, this shows that we are actually following. So we import it from the metrics module. That's good. We'll say dot metrics import accuracy. All right, so you can easily just do this because you're importing a lot of things. So I can just do something like this. Import accuracy score. Import precision score. Import recall. F1 score. Classification report. Confusion matrix. AUC score. All right, so let's just leave. These are the ones that we'll be needing. So import all this. So what else I'm going to be importing? So so now I also want to set, because I might be okay, never mind. Let's just leave that. So we imported this. What else? So we import for the preprocessing tags from scikit-learn.preprocessing. Import. We're going to be using SimpleImputer. SimpleImputer. We're going to use let's say label encoder. We're going to use OneHotEncoder. So let's just import this state. Okay, scaling too. So I can just import scaling as well. So import standard scalar. Import so I'm just going to use min max scalar here. Just use min max scalar. All right, so these are what I'm going to be using. So let's just start with this first. So you can see how neat my import libraries are. So I separated. This one should anyways, let me just make this import matplot plot. So ideally, according to Python, you should actually separate this kind of import from this kind of import. When you're importing from a module, you separate it from when you're importing directly. So that is basically it. You kind of just give a single line and then you continue with the other one. So it's just to like make things look clean and all of that. Let's just move. So the next thing we're going to do is to import our data. So you can do that with we've done that already. So let me just copy it here. So I'll just copy and come here straight up. So I'm not going to be going through every step. I'll just go through major steps. I'm kind of going to just breeze through because we've done all of this. So I'm doing this so you kind of have an idea of the flow. This is not exactly what, but this is like the flow basically. So you import your data sets, and then after you've imported it, you just examining my data or exploring my data. All right, so I can come here and see. Let me see what my data is like. df.info. All right, so you can see that we have 50,000 rows. We have how many columns? We have 14 columns. Okay. So now, if this is a machine learning project, you need to you actually need to. Pandas is open already, so please you can go ahead and sign. So I think you need to figure out which particular column or variable is your target variable. All right. So in this case, let's just use this particular column here, booking complete, as our target variable. All right, so we are going to keep that in mind. So the rest of this is going to be our features or our input or independent variable. All right, so you can see we have all of this here, right? So I can just quickly explore them. So we can now see each of them and just say dl.head and just look at our data set. So, okay, this is what our data set comprises. So you can see we have our booking. So our booking is actually a binary, zeros and one. So booking complete, 0 means it was not completed, 1 means it was completed. So we have all of this in our data set. So you can explore, do a lot of other exploration and all of that. If possible, you can also use chart as well, right? So there is a particular function, I think either describe or summarize. Let me see each of them. Okay, describe. So describe, I'm going to just transpose it. So it gives me, so describe is just going to describe my numerical variables, like just kind of very brief statistics. You can see I have the count, I have the mean, I have the standard deviation, and the other quantas. All right, so this is just giving me a summary, all of that. So you can actually also check other stuff here. So we're going to be seeing, let's see our columns, right? So we have, let's go back to our column. We have number of passengers, where is a good column. We have sales channel, we have trip type, right? So we have all of this. So this is just exploration. You're not doing anything yet. You just want to understand where your data is, right? That's exploring, right? That's what it is. So so you follow some other techniques that we've looked at before. Like I really don't want to do every single step. So you don't follow this like letter for letter. Like I'm just doing this to help you have an overall flow. So this is not what I expect you to do. Like I need you to get that. I expect you to do much more, better, and be creative, basically. So you don't necessarily have to use exactly or you're not confined to only what we've done in class. Let me just say that. But I think someone asked that question. You're not confined to what we did in class. You can use other things that you probably learned somewhere else. I will even appreciate it, but I will actually be impressed if you do that. So yeah. So after you've explored the data, you now go ahead and what's the next step? So you are going to be taking me through this step. So what's the next step after exploration? So I'm going to have something like this. But let me just give you a tip. I expect you to use your markdown at every stage. So after your importing library, I expect you to use a markdown to indicate, okay, this place I'm going to import or give me this thing. What's happening? OneHotEncoder. Okay, I think there's a okay. Can someone tell me what the problem is in this place? I didn't even see it. Can someone tell me what the problem is in this place? I'm waiting. Can someone tell us what the issue is here? Because we're obviously getting an error. So we need to know what you can see the error here. And I don't want you to see the error actually, because the error is going to give the problem out. But I just want you to look at this line of code now that I highlighted. I want you to thank you, Gabriel. Thank you, Gabriel. We are importing SimpleImputer from the wrong module. All right. Thank you, Chinedu or Wemimo. So we are importing SimpleImputer from the wrong. We are supposed to import SimpleImputer. Nobody even corrected me. So we're supposed to import SimpleImputer from input module. So come here and just import SimpleImputer. All right. So this is just basically it. So it should not give us this thing again. That was successfully executed. So we'll do this and that. So I expect you to come here and say something like this. Loading our data set. So you can see how if I'm going through it, I'll say, okay, this is the stuff, importing library, okay, loading data set. Okay, so everything under this place now is for loading data set. Now, once you're done, you can just come to the next place, create a markdown, say exploit data set. Next one, EDA, this, that. So, like, this is the kind of structure that I should expect, something like this. So this is just an hint. I think this is where I'm going to stop with the hints. So I allow you to just be creative with the whole thing. Okay, so now we've done this. So I'll just move ahead. So next we can just clean our data. Data cleaning. I'm not going to do much data cleaning because of time. So cleaning our data. So we're going to look for problem with our data set. So first thing we'll check for missing value. Check for missing values. I can just come here and just say let's say df.isNA.sum. Very simple line of code. So you can see we have a lot of missing values here. We have these, that. So now this is something we need to work with. All right, we need to clean this data to remove missing value. So how do we do that? Now you can either decide on using Pandas to do that, or you can use SimpleImputer. So in this case, I'm going to use SimpleImputer. I'll say using SimpleImputer to handle missing values. So first thing I'm going to do is that because the missing values are spread across different data types, you have missing values for categorical data and you have missing values for numerical data. So you have to separate those data types because you can't use the same strategy for both of them. What I want to do is I want to just apply the transformation to all the columns involved at the same time. I don't do it one by one. So I'm going to separate the data into numerical and categorical set. So how do I do that? I'm going to come here and say number. I'll say pd.select. Is it PD or DF? It will be PD.select DF.select. Let me just try to see if it works first before I move ahead to, I think it's DF, right? So yeah, DF.select the types. So what am I going to do here? I'm going to say exclude or include what? I can just say numbers, right? Or let me say np.number, right? And I can easily just say this as all right. I think this should run. This is for the numerical variable. So for categorical variable, I'm going to just say categorical variable df.select the types, and I will exclude number. So I can say np.number. You can just do the same way I did it before, where I'll just put number here. All right. So, but let's do it this way. So you have these two. So if I come and say number, you see that I have just the numerical variables here. Let me zoom out of here. You see that I have just numerical variables, all right? That is 9 columns. If I say cat var, I have just the categorical variable. So this is the first step before we start cleaning. But before we even start replacing missing values, I'm going to actually look at my data set. Before we even do all this, you're supposed to even look at your data set and check. Let's come here. DF, right? Like there's some data sets, there's some variables that don't really make sense here. Let's look at it. So we have route. This route, it won't really make sense for our machine learning stuff. Booking origin, that we have to remove it. All right. What again? So we'll remove these two for now. All right. So because I'm not really doing anything for us, so I'm just going to come here and drop them. I'll say df.drop. I'm going to say axis equals to 1. And then I'm going to say column equals to, we have routes here, and we have booking origin. So I'm going to drop this. I'm going to say df equals this. Before I drop that, I'm going to do something like this, because this dropping stuff can mess up with your data. So I'll just create a copy. I'll come here and create a copy. I'll say creating a copy of my DF. Although you've not really made any changes, right? But I'll just create a copy, right? It's good. So I'll say df.copy equals to df.copy. Okay, so we're now going to use our df here, our original df. So in case anything happens, let's run this. In case anything happens, we can always come here and say df is equals to df copy. Right, so we are sending it back to df, as simple as that. So let's drop this. We're gonna have this. So we remove those columns here. Now we do the same thing here. We have just 3 categories. For numeric, okay, we didn't drop any numerical variable, right? But I think everything we can use everything, right? All right, so let's proceed. So now that we've done this, I'm not going to do EDA for you. I'm not going to do EDA, right? So we've done this. Now we want to like handle our missing data with SimpleImputer. So we imported SimpleImputer already, and then missing values. So you create a SimpleImputer transformer object. So I'll just say simple. I'll just say SimpImpute equals to SimpleImputer, and then strategy. So this one is going to be for SimpleImputer cat. Sorry, num. This one is going to be for the numerical variable. So SimpleImputer strategy equal to mean. Let's use mean. But you know we are supposed to look at the outlier. I'm also going to, during cleaning, you look at your outlier to see if there's any outlier in your data and clean it before you proceed to using mean, because mean is not robust to outliers. But let's just assume that the outlier has been dealt with. So this for num. We also create another object for another SimpleImputer object for a categorical variable. So I'll come and say SimpleImputer. I'll say strategy equals to what? Most frequent. Okay, so we've created the transformer object. So we created the transformer object, and then we can just apply it to our data. Applying the transformer object to our data. So for the numerical data, we can just say s.impute num.fit transform. So I'm using fit transform at the same time. So I'll just come here and say what was that again? Number. Okay, number. And I'll come and say SimpleImputer cat dot fit transform cadva, so categorical variables. So this is an approach you can use in preprocessing our data or cleaning our data. We also have what we call pipelines in scikit-learn. Pipeline is a way to kind of just chain all the preprocessing steps into one. We're going to look at pipelines at the end of this program, or before we end this program, basically. So it's a very nice and neat way to do things, but this one is like the traditional way or the default way. So we'll do this, and obviously we should assign it to say new norm, and you can say new cat or cleaned norm or cleaned cat. Anyone that you feel would be better, you can just come here and run it. So we have an error here. So what are we going to do? So put equal to, and then we have this. So if we come here and we check our new norm, remember every transformation we do in scikit-learn always return what? An array. Is always returning an array. So we have to convert that array back to what? A Pandas data frame. If we still want to work on it, right? It returns an array. So we can convert this to a Pandas data frame. But let's see the other one, new cat. So you can see the categorical variables. There are 3 of them. It has replaced everything. And we can see the numerical new norm. Okay, so we can easily convert this to a data frame. Say convert output to df. So we'll just say come here and see df, or say df cat or df norm equals to pd.data frame. I'm going to say new norm, and then with our column. So which column are we using? Norm var.column. So remember we have norm var here. We created, where do we create norm var? We created norm var here. So norm var is still data frame. So you can access all the data frame objects and attributes rather. So I come and say column. If I say norm var.columns, it's going to give me the columns of our data frame. So that is exactly what I'm going to do here. So the columns here will be equal to norm var.columns. Okay, so I'll do the same thing for cat, and I'll say pd.data frame, and I'll say new cat, and say columns equal to cat var.columns. Okay, so if I run this, it should work fine. I just come here and say df norm. You can now see my data frame here. I can say df cat. So I can just come back and merge both of them. I can say merging both data frames. Okay, so now I'm going to say df equals to then pd.merge. I'm going to say df norm and df cat. So where are we merging them? I think it should be on the column. So if you forgot, you can just check merge. So you can see, okay, let's use concat. Actually, concat. So concat is better. So you can just specify the axis to be 1, right? Don't concat it on the x-axis, sorry, on the y-axis. So let's see. It is supposed to be in this format. So if you check our df now, you can see that we've gotten our df back. So you can see the steps we took just to clean our data with SimpleImputer. There are more steps basically, right? So you can just do that and you get your df back, and then you can say df is NA, and just to confirm if the stuff that we did has, so you can see that everything, all the missing value is gone now. Like we've actually cleared the missing value. So this is basically how you, like the flow that you would take, right? The general flow you take when working with SQL. So the next thing we can do after that, let's just assume we've cleaned our data, we've done all the cleaning and everything. Now we want to like pre-process our data. So you can come and say data pre-processing. So let's say we have, obviously, we have, I don't think we should even concatenate now. We should concatenate after we are done with the pre-processing, because we want to also apply pre-processing based on the data type as well. So I'm going to just move this down. I'm going to move this down. Yeah, so it's going to be after we are done with everything. All right. So let's still get our df cat and df num. So we want to encode our categorical variables basically. So encoding categorical variables. So we've imported our OneHotEncoder, right? So we just create a OneHotEncoder object, OneHot, and then we can come and say OneHotEncoder. Okay. So let's first say first output equals to first and then output an E here. So OneHot.fit. So I'll be fitting the categorical variables, which is df cat. All right. I'm just going to do fit and transform together. Transform. Transform. So I'm going to have encoded cats. All right. So one thing about data science or programming, that you have to be creative about variable naming. So you can see how many variables I've named like in just this short period of time. So you have to be creative about naming variables. So just make sure the variable is descriptive of what it is you are assigning it to. Okay. This is for encoded cat, and then let's scale numerical features. So I'll just let's use min max. So I'll just say scale. I'm going to just say min max scalar. Okay. So scale dot fit transform. And then I'm going to put df.num. So I'm scaling all the numerical variable. All right, every numerical variable. So I'll just assign it to scaled num. All right. If I run that, if everything is correct, it should give us our output. So now we're going to just come here and let's quickly look at it before we concatenate, right? So you can see our encoded cats. These are encoded cats here, right? We're going to have to convert it to a data frame. So converting output to df. So this is just a very, very brief a summary of what you're supposed to do, right? But I'm just trying to. So you convert it, then you say still you can use the same thing. df num equals to pd.data frame, and I'm going to say encoded cats, right? And columns is going to be equals to OneHot dot get features names. I hope I get the stuff correctly out. So that's for the numerical. So for categorical, we'll just say df pd dot data frame. I'm going to num, then columns is going to be equal to df num. So what am I even doing, sir? This is what we cut. This is supposed to be num. So df num dot columns. All right. So I know this feature name stuff is. Let me try this. All right. So that's perfect. There's no S here. So then we've done that. So we can now concatenate. So if we check our df, let me just create it anyway. If we check our df cat, you are going to see that we have like a whole lot new columns, categorical variables. So this is one hot encoding. This is how one hot encoding will look like basically. So we're now going to concatenate it with, let me show you the scaled one. This is our scaled, numerical variables. You can see that all these things have been scaled. Now, like this is the original stuff here. Let me show you the original stuff. So we have df.num here. Anyways, yeah, the original stuff is just in this data set. You can check it out here. You have your number of passengers, you have your purchase lead. So all of them, they're in different scales, right? This one is in 100, 262. This one is in 2, 1, 2. So your algorithm actually needs your numerical variables to be in the same scale so it can converge faster, it can work efficiently. So if you are, sometimes you might have a particular column that is in millions, in like it's like 5 million, 4 million, like, and then you have another numerical variable that is like in tens, like 10, 20, 25. So the discrepancy is not good for your algorithm, basically. So that's why you need to scale everything to be in the same scale, okay? So that's why after scaling, you're going to have something like this. So everything is between the same scale here. You can see 0.125, 0.3, but they still have the same meaning, right? The same meaning that they had initially is still there, just that the scale has been changed. That's basically what scaling is. So for those ones that are ones and zeros, like it's obviously just leave them like that. And so that's basically it. Then you can now concat, go ahead to concat your stuff. And we'll have your df here. Oh, that doesn't. You have your df. So you can see your df is now ready. So what's our shape? 21. We now have 21 columns. From what? From how many columns initially? What was our column size? We had 14 columns initially. So now we have 21 columns. So now you can now start to separate your data into features and labels. So you say separating data into features and labels, or features and, yeah, let's just call it labels, right? So our feature now are everything except, because our booking complete is what we want to use as our y variable. So we're just going to do that. So we'll just say x, you can name it x. This is the most commonly used variable, equals df.drop booking complete. All right, so that is on the y axis. Sorry, yeah, on the column rather, on the y axis. Okay, so you do that, and for your y, you can just say df booking complete. So this is how you just like assign it. So if you check your y now, your y is this, all right? So let me check. Hope my y as okay, 0 and 1. So your y is binary. It has 2 classes, 0 and 1 class. So that is it. So check your Y shape. So sorry, is the one that is one dimensional, right? So there's no need for label encoding for your Y. Okay. So, but mostly something you have to do is, like, let's say before you even encode, like you separate your X and Y before you do all these things. So this place I'm separating it now is not meant to be here. I actually meant to separate it before you start pre-processing. So you pre-process your features separately from your Y, from your labels, okay? So take note of that. That's why this exact flow is not exactly what you should do, but it's just to give you an idea of what is expected. So check your Y shape, check your X shape to ensure they're corresponding. So you have 20 features and Y you have 1. That's fine. So you can now go ahead and now split your data into train and test. All right. So remember, we not do EDA here. EDA should be done, obviously. Like using each column, you perform univariate analysis, bivariate analysis, get insight, try to understand how this affects booking, complete, which one. So there are a lot of things you can do in EDA, but I'm expecting you to just give me at least 5 insights from them with visualizations, very nice visuals, right? And all of that. So you should annotate your visuals well. You should use all the things that we've done so far. So let's move on. There's no time. So we have to split. So the way to split is using your test train split. So I'll come and say S train X test. So Y train Y test. So your X is always in capital letter. That is the conventional way of doing it, and your Y is always in small letter. I can come and say train test split. And I'll have my X, Y, random state. Let's just use 20, 25. Let's just say 25. And that's it. Okay, we have, what are we missing here? There's something I'm missing here. Can someone just tell me? I feel like I've just been doing solo since. So what am I missing there? What parameter am I missing? All right, thank you very much. So that's test size. That's actually great. Our mind is very sharp and we're remembering everything. So we'll say test size. Let's say, so you are the one that will decide on the test size to use. So in this case, since we have 50,000 data, I can just use 10%. Even 5% is okay because I want to maximize the number of data that will be allocated to my training data sets. Okay, so you need your model, your algorithm to see enough of the data that it wants, you want to train it on. So let's just keep our test size to be 10%. Sometimes you can even make it 0.05%, right? Since you have a lot of data, if you calculate 10% of 50,000 should be 5,000, all right? So, and 5% should be 2,005. So that is even still enough, more than enough data to test your model. Okay, well, let's just go with 1%. Okay, let's just go with 1%. We've not imported this yet, so we are going to come here and import it. So where is that? All right. Okay, we are going to import that here. Okay. So from which module do we import test train split? Train test split. From which module? This is nice. Yeah, model selection. I love the activeness. So model selection, we import train test split. Run this stuff again, and then we move on to that, and then run this. So we're going to have an error because we forgot a comma somewhere, which is here. Then we're going to run this again. So our data has been split. You can just confirm by confirming the shape. So S train should be the same thing as Y train. right? So S train is 45,015. Y train should be also 45,015. Okay, just confirm it to be sure. You check X test is 5,000, all right? So 5,000, Y test should also be 5,000 and one dimensional. So just confirm the shape before you proceed. So you can, let's say, confirm the shapes of the split of the new data set. So you can see something like print X test dot shape 0 equals to Y test dot shape 0. All right, so we're just going to copy this and for train. So you should get true for both of them. You should actually get true. So once you get true, that means they're actually the same. They have the same shape, so you can move ahead. The next thing you do is anyway, you know, we're not done with this ML, so there's some other things we're going to look at in class that you need to include. But the thing you're going to do is just go on to building, selecting, and building your model. Okay. So since we've only worked with logistic regression, we're going to use logistic regression. But next class, we are going to look at other classification algorithms. So obviously you would have to use like all these other ones together with logistic regression or whatever one that you want to use. So the aim is just to get the best performance. So anyone that can give you the best performance is your best bet or is your best choice. So in this case, I'll be using logistic regression, right? So I'll just create a logistic regression object, logres object. I'll come and say logistic regression. Okay, so now in this model building part, there is what we call hyperparameter tuning. That's the class on its own, hyperparameter tuning. So hyperparameters are those things that you can tune to that would affect your weights and affect your performance of the model. So everything that is here, all these things that we have here, they are your hyperparameters. So I'm going to look at how we can actually tune them using randomized search and grid search. So those are tools I would introduce as well. So in this case, we really don't have much, but let's just change this to max eta. I just work with max eta in this case. You can see we have other hyperparameters. All these things that we have here, they are called hyperparameters. Normally they are called parameters, but in machine learning, they are called hyperparameters, right? So take note of that. So parameter in machine learning are those things that are learned during training. Those weights that are learned during training are the parameters. So parameter is like, you can equate parameters to knowledge, right? So remember, if you ever had anything like OpenAI built another large language model with 1 billion parameters or 100 billion parameters, or 100 billion is too much actually. Let's say 7 billion parameters or 100 million parameters and all of that. So those parameters are actually what the AI model has learned during training. So that is the core knowledge. That is the thing that determines how well the model will perform, basically. So parameter is the main thing. So the thing, those parameters that you use to change the parameters of your model, they are called hyperparameters. So hyperparameters are those parameters that can be used, that can be tweaked, or that can be changed to affect, or that will affect the parameters that your model will have at the end. All right, I really hope that is clear, because this is a very, very key concept, parameters and hyperparameters. So in your model building, anything that is inside Brown, remember in Python generally, we call anything that is inside your function or your class parameters, all right? But in machine learning, they are called hyperparameters. So that is just the difference I need you to note, right? So I hope we are clear. I hope that is clear enough. I hope everybody's still following. You can see me very clearly and you can see my screen. We're wrapping up already. We are actually wrapping up. We're at the end. So don't worry. I'm going to be like wrapping up very soon with it. All right, great. So so now we are going to create a logistic regression object. Fine, we've done that. You can include a lot of stuff here. So when we look at hyperparameter tuning, we are going to like focus more on this. So now we have our data. So we are going to now train our model. So doing that, we're just going to call the model object logreg.fit. And I'm going to say x train, y train. I'm going to change this to 1000. All right. So after that, I'm going to use my model to making predictions with my model. This is a very simple way. Like this is not what you'll be doing basically in your project, but this is like just as I've said repeatedly, flow to help you understand the flow. So I can now use my logreg to make predictions. So you can come and say predict. So there are two. Let me like I don't know if I've showed you before. Have I showed us this predict proper function before? Have I showed us predict proper function before? Please let me just get response quickly. Have I showed us predict proper function before? Now. All right, so I'm going to apologize in advance now that we're going to overshoot a little by 10 to 15 minutes. Please, I just want us to wrap up with this class. I'm apologizing that we would overshoot by 10 to 15 minutes. So please just stick with us and exercise a little more patience so we can wrap up with this. All right, so predict proper gives you the probability, the raw probability. Why predict gives you the class itself, all right? So let's go there. So predict, and what we're going to put here is going to be our X test. We're going to pass it to what our Y predict, Y pred. All right. So we're making predictions. All right. So that's it for Y. So now we're now going to now start evaluating our model. So to get your the first thing you just have to do, just get your accuracy first. Accuracy score is equal to dot accuracy score, I think, is Y tests and Y grade. So you can see that our accuracy score here is 84.7%. So which means that our these are good performance is. But now, we've not checked the ratio of our label, the label category. So you can just come here. So let me just quickly check the df booking class booking complete, right? I'm going to say dot value count. So you can see now that this is our ratio. So is this data set balanced or imbalanced? Let me hear from you. Is it this data set, is it balanced or imbalanced? Exactly. Balance. Balance at all. You can see that I've not heard from our assistant class rep today in Nigeria. I hope she's okay. So you can see that we have 42,000 number of observations, or instances for incomplete booking. Why complete booking has just 7,000? So it is lopsided, like very, very low. So we can't trust accuracy here. So this accuracy is not going to be a good metric to judge our model performance. All right. So we can just now you can include this in your summary and recommendation. You can see we let's say after you are done, you say accuracy in this case is not going to be a good metric to evaluate our model, because after checking the proportion or the ratio of our label categories, we found out that the data set is imbalanced, basically, right? So making accuracy to be biased towards this. So you just like I need those kind of statements after you are done, right? So I need to know that you understand what you did and you don't just follow blindly what we have been doing in class. So now we're going to move on to just checking the confusion matrix, right? So getting the confusion matrix. So to do that, we're going to come here and I think did we import? Okay, we imported confusion matrix. So I'll come and say confusion matrix equals y test y print. So this is it here. So I think SNS has its born. So I can just see max. SNS has a heat map. I think heat map. Let me just be sure. Heat map. All right, great. So it has heat map. So we can just like pass in our confusion matrix to it, and we're going to get. We should get something like this, right? So now we're going to do some things like, let's say figure equals to plot.fig plot.figure equals to fig size. Then we're going to have 10 and 8. Alright. This is too much, okay? Let's say 6 and x should be 6. Let's just say 4. Alright, let's make it smaller. 4 and 2. Alright. Annotation. So we should actually annotate it. Okay, annotation equals to true. All right. So, anyways, this is not time for visualization. So this is how you can get your confusion matrix, right, to be displayed in heat map. So this is used for heat map. Right, so there's a way we can just get the values for each of these things by using annotation. Like time has gone, so we won't even look at that again. So basically, you've gotten your confusion matrix, which is this C max. All right. So you can see here that we have 4, 2, 3, 8 here, and then we have 0, 0, 0. So this is basically giving us the true positive. So this place is the true positive, this place is the true negative. So diagonally from left to right are the true positive and true negative, and from bottom to up diagonally is our first negative, first positive, right? So you can use this to assess your model, and then you can just use classification report as well to get the overall classification report. So everything follows the same pattern here, y test, y print. So let's quickly just do print. So you can see your precision here and all of that. So everything will be displayed, so you can start interpreting your metrics and all of that. So you can move ahead to check your F1 score, your precision, your recall, and even your ROC AUC curve. Okay, so there is actually I've not showed us how to work with ROC AUC. So let me see if I can do that. ROC AUC ROC curve. All right. I hope everyone can still see my screen clearly and can see hear me clearly. Please, I want to be sure. All right, great. So we have ROC AUC score and ROC AUC curve. So we can actually get our ROC AUC score, and let's see here. So ROC AUC score. So I'm going to just come here and say why true, why print, why test, sorry. So you can see that our ROC AUC score is 50%, 0.5, which is a better reflection of your model performance. All right. So this basically tells you that your model is not really performing well. So we're supposed to like visualize this, but I'm actually leaving this for when we start, like when we actually introduce other models, right? Other algorithms, basically, we can now use ROC curve to compare the different model performance. So at that point, we'll actually dwell more on ROC AUC score, right? But basically, this is the flow that I expect from you. You would import your data, load it, clean, explore, clean, perform EDA, which we didn't do, preprocess, and everything that we did today, basically. So this is the a basic end-to-end approach to machine learning. All right. So these are like a kind of summarized version of it. So it's a lot more. Like obviously, I can't actually do a whole project in a single class. So this is just an abridged version of it. There are a lot of other things to put into consideration. And as we actually progress with our class, we are going to be introducing something that you'd also have to include in your project as well. So I think that is going to be it for today's class. I feel this should suffice for data preprocessing. Like this is a good place to start from, and we can pick up from there. We're going to do a lot of other things moving forward. And I'm still looking, I've not concluded yet, but I'm still looking at fixing a class anytime this week. It's not going to be Friday. So it's either Wednesday, Thursday. So I'll do that, and then we can just look at some topics that we need to look at. So that's going to be it. We'll be drawing the curtain there today. And I'm going to be providing the project either today or tomorrow. So just anticipate it so you can start as soon as possible. And there's something So basically that is going to be it for today's class. If there's any question, please just indicate quickly. If there's any question, indicate. Okay, Abdulhamid, please ask your question.
Can you hear me?
Yeah, I can hear you.
Yes, I just want to ask regarding the capsule project. I think like we said, you've already told us that we can use any, because we must not actually follow your blueprint in the class the way you have done it in class. We can use any way to do, anyhow to do it, just to ensure that we get the answer done. But when you My question is, I think if we want to put it anything, we should be able to use there should be a features, there should be some feature that we are going to work with, not that we just work with all the features. I think you should be able to give us that we should work with some of the features, and we have the features and the target that these are what you need, so that at the end of the day we'll be able to have something to like a visualization, like maybe we'll be able to have it like the normal way we normally present our model, like the linear model. Now we have y is equals to beta naught plus beta beta 1x, something like that. If we have like 4, we should be able to present it so that we'll be able to generate our intercept and all those stuff as well. That's what I just want to know, so that it will not be as if we just combine everything together. Some of those features might not be necessarily used in predicting the what we want to do, what to work with. And also because of the fact that the domain that we are working on, not all of us is very familiar with that domain. We should be able to work with some features, not all the features. I just want to ask if you can work, if you can.
Okay, thank you for the question. So basically, yeah, you can deviate a little, but don't over deviate that I begin to wonder what you're doing. So you should still like follow generally the blueprint of what we've done in class so far. Okay, that's why we're having this class. So obviously, if I look at your project and I don't see anything that we've done in class, I will assume you are doing something else. So the essence of the project is for you to combine everything you've done so far, and then you can now add a bit or extra stuff that might help you or that might make it better. You understand? So I don't say you should deviate entirely. You would have to follow what we've done, but you can add if necessary. If you think there are some things that I forgot to mention that you can that will help you with your project, you can just add them, right? So that's basically what I'm saying. And as for the feature selection, we are going to have a class for feature selection where we're going to talk about how to select features that will be relevant for our particular model training. So, and I'm not going to be the one to tell you which feature. It's part of your job as a data scientist to figure out the features that are important. So when they give you a work as a data scientist, the person, your manager or your supervisor giving you will not be telling that, okay, this feature is best. You're the one that will determine which feature is necessary and which feature is not. You can see how I did it. So this one is just based on my domain knowledge. I know that these particular features are not important, right? So but there are some techniques that you can also use to know relevant features that should be used. So we also have that in our curriculum as well, right? So that's basically it for that. I hope that answers your question. So Solomon, ask your question. Your hand is up. Please do that as fast as possible.
Okay. Hello, good evening. Can you hear me?
The voice is a little bit, it's not so clear. I think it's kind of muffled.
Can you hear me now?
Yeah, it's better now. Please go on. Go ahead with your question.
Please, I don't know if you can hear me now.
I can hear you. Oh, I think network is messing up. Cherish, please ask your question. Solomon, you can ask your question when your network comes back. Cherish, please ask your question.
Okay, good evening.
Yeah, good evening, Cherish.
Okay, please, I want to ask, because there was some time ago that you gave an assignment that had something to do with customer list data sheet. Okay, then the system I'm using is not accessible. It's not accessing the Jupyter notebook. So I spoke with the assistant class rep, and she advised me to use Google Colab, which that's what I've been using all this while. But that very assignment that was given that has to do with customer list, I was unable to navigate that particular one to get it into the sheet so I could work with it. So though I know I've asked her that question, but I think maybe she didn't see the question or something.
So what exactly is the question now? Like, how do we come in?
Okay, how to get the customer list, the file, to be in the same
Okay,
page.
okay. I thought you said you've been using Google Colab ever since. So exactly how you've been doing it, you just have to continue with that. So I think the way you do that is just to put your data set in the same folder, because your Google Colab is in your Google Drive folder. So you put it in the same Google Drive folder, then I think it should work well from there. Okay, so yeah. Have you tried for your Jupyter notebook? Have you tried, like, was there an Anaconda you installed for it
Yes,
and it didn't work?
yes.
Okay, I don't know if I think some persons had that issue, and I do show them how to. Anyways, it's actually a long process, because you can install Jupyter Notebook separately without Anaconda, but you have to install every other package that you'll be using. So it's actually kind of a house. But just continue with your Google Colab. I think the same way you've been doing for your assignments, you can still work for your project as well. So just to ensure that your data set is in the same directory or folder in your Google Drive as your Google Colab notebook. All right. So Solomon, your hand is up again. Please go ahead and ask your question. Cherish, I hope I have a
Yes.
question.
I
All right,
appreciate
thank
it.
you.
Good evening, sir. Can you hear me clearly now?
Yeah, I can.
Okay. Yes, it's as regards to data cleaning. I want to ask, in a situation where you have almost half of the values in the futures are no values, especially in the categorical variable. Because yesterday I say using the most frequent. If we have almost half of the data set that in a particular column having no variable, if we use that most frequent, don't you think that it will tend to be biased and be sidelined? Is there a possibility where we can be able to share, maybe distribute evenly between all the other features so that at least it could be more balanced?
Sorry, can you just come again? I think I lost you at some point. Just a summary of what you just said now.
Okay, I said in a situation where you have a particular column having have almost no value, half of it are no value. Is there a possibility whereby instead of using the most frequent, which will also make it be more biased, can we evenly distribute that no value to some of the features here? So that at least each of the values in those columns can have almost an even number, so that it will not be just biased to a particular person.
Okay, I think if I get what you're saying, you're asking what to do when you have a column that has null values, like a lot of null values, basically. If you have a column with a lot of null values, like the null values are more than the actual values, just drop the column. All right, just drop it. You don't need to stress yourself, because the extrapolation you'll be doing and the whole lot of stuff you are going to be doing might not really reflect the actual data. So you just drop it. Just drop it, okay? So that's just the best thing to do at that point. So if you have a lot of null values in a particular column, there's nothing like, you don't have to start trying to figure out how to like replace them. Just drop it. Just drop drop the column, don't drop the null value. I hope that is clear.
Okay.
Don't drop the null. Drop the null values. That means you're dropping almost more than half of your data sets. Because you drop other columns, you drop the column itself. Don't drop the null value. So I hope that answers your question. All right. So thank you very much, everyone, for your patience and all of that. So we've come to the end of this class, and we are wrapping up with the entire thing, right? And I'm happy that we've come this far, and I'm also proud of every one of us here. We are actually very resilient to be able to make it this far. So as usual, please do well to look go through the recordings, right? I made sure that the recording for this class was made available immediately, right? So this one, I'll try to make it available as well, so you can go through it. So please do well to list out and to point out the things you've learned in today's class. I don't need to be saying it in every class. Just know that this is a routine, basically. So because I didn't say yesterday, so just point out, write out those things that you learned in today's class. I really want to see it, and I would be interacting with us in the chat. Okay, so that's going to be it for the end of this class. And something else, for this project, like for this cohort, basically, the person that comes up with the highest score generally, both for project and assignment and all of that, you're going to, I announced a particular advanced class I'm going to be doing. That person is going to be getting it for free, right? So you won't be paying for it, so you'll be getting it for free. So just take note of that. The advanced class I'm going to be having, right? So the person that would have the highest project score and assignment score and everything would be having it for free. So that's actually that is it about that, and we're going to draw the curtain at this point. Thank you very much. Enjoy the rest of your day and have a splendid week and a beautiful month. Good night.